Welcome to my blog on cybersecurity and big data. My name is Lim. I'm a computer scientist and educator and a software engineer. Today, I'm going to talk about how to do alert triage or investigation using SQL notebooks and Graphistry. Let's jump right into the scenario. Basically, what I'm going to do is I have access to 3 email alerts, or you can think of this as emails from a abused email mailbox where user-reported phishing emails are stored, and I'm going to investigate one of them. And I'm going to assume that I only have access to Zeek data, which is basically a PCAP data from your network appliance that I'm going to pass using Zeek into the standard Zeek logs and using the Zeek schemas. So let's jump right in. This is a query to pull out the list of email alerts. I'm going to look at the first one. And in this particular case, I look at the headers and I see that, hey, it was delivered to macros.com and enemywatch.net. Enemywatch.net is my company, my fictitious company, actually, for this investigation. So let's investigate this email alert. And basically what I want to do is determine if this is a true positive or a false positive. I'm going to dive right in and start with the authentication data. What I'm hoping to look at is what are the machines associated with the recipient. So I wrote a query with the event date, and I look for the recipient being, the client being macros.com containing that string. Query returned no results. So something is off. Let's just try the last name. And indeed, when I change it to just the last name, I did get a bunch of records, a bunch of authentication records, actually. And in fact, it's for marcus.com. So there was a misspelling in the email header, which is indication that the email header could be tampered, just to make this a little bit more difficult. But from these authentication records, I see that marcus.com is associated with 10.10.22.157. And I look a little bit further to the services that was authenticated. I do see a host, a desktop, NZ875R4. So this could be the host that's associated with that IP address. So that's what I'm going to confirm next. And I'm going to scroll down. I'm going to check the IP address. I'm going to use the DNS records for this. The DNS address that the 10.10.22.157 resolves to. I can actually start either way. I can start with the desktop -NZ875R4, and that's what I did here. And I see that the DNS answers actually maps back to 10.10.22.157. So I have established that this IP address does belong to this desktop, and this desktop is associated with this recipient Marcus card. So what next? Well, let's look at the traffic to and from this machine. And that's what I do with this query here. I first look at HTTP traffic. I only got 2 records, which are not terribly interesting. Nothing looks suspicious here. So I'm going to go on to connections. And Zeek provides a connection data type that shows you all the data connections. And this is what I'm doing with this query here. I'm actually going to do a group by on source and destination IP, as well as the port, and I'm actually going to sum the bytes that were transferred between the connection, within that connection. So these are the results that I got. I sort them by the total number of response bytes. And you see that, hey, the top communication came from an external IP address, 37.0.10.22. Next is 8.8.8.8. This is just a Google DNS server, so nothing too interesting. The rest were 10.10.22 network, and so those are probably all from the same local that's local to the company, the internal network. So this first one is something that I will investigate first. So it does look to be potentially problematic. So let's take a look. And so what we do is let's check the FQDN for 37.0.10.22. Okay, we do a DNS query for that. And this is the query to do the lookup for when the answer is an IP address. And we see then that, hey, it maps to this domain name, which looks pretty funky. The first part looks somewhat random. So it could be generated by a domain name generating algorithm. And that would be very suspicious because a lot of C2 servers actually use DGA algorithms to generate domain names. So that's kind of suspicious. And so what we do next is we're going to do a little bit of Google research, and we do find that from VirusTotal and from Recorded Future. Those are two threat intel providers. We do find that, hey, indeed, that domain name with 37.0.10.22 belongs to a C2 server for the NanoCall family of malware. And you can look up the links here, and I will not go into that. So at this point, I have established that there is communication from this host to the C2 server. I'm pretty sure that this host has been infected with the malware, and that the user has indeed downloaded the malware from the email and executed it somehow. So this is definitely a true positive, and that host now needs to be remediated, isolated, contained, and remedial actions taken. So this was using just pure SQL, and you realize that you do have to know the schemas, you do have to know the column names, the table names, and you do need to know how to write SQL. Let me show you something cool. Now, you could actually augment this with Graphistry. Graphistry is a graph visualization package, and this notebook, I'm not going to go into details, but this notebook would pretty much generate a graph on the fly using view. So this is schema on read. We're not materializing the graph data model. So it's going to get the vertices and edges from the Zeek data, and then it's going to send it to Graphistry, and Graphistry is actually going to render it. So this is the rendering of the graph, and this UI actually provides you with some investigation capabilities, and I'll show that to you next. If you want more screen real estate, which is what I like, I'll pop it out using this button here and open it in a new window, and this one I did already here. So this is the Graphistry tab, and I have the entire screen here with the graph, which is a lot easier to look at. I would use the data table tab. And with this, I can actually search now for Marcus Cobb. I just do Cobb, and it straight away filters down to the two edges containing it. So I'm just going to click on one of them, and it quickly highlights the node, right? The node where Marcus Cobb is involved, is labeled. And so we see that this is the Marcus Cobb node. And if I click on it, I see that I straight away see that it is associated with 10.10.22.157. And if I look at 10.10.22.157, I straight away see that there are a lot of communication, a lot of connections to 37.0.10.22. And I see that 37.0.10.22 is associated with this domain name, which we know is the one generated by a DGA algorithm. And then from here, then I can actually now do a bit of Google research to determine that, hey, this domain name and this IP address indeed belongs to a C2 server from the NanoCall Red family of malware. So this was very obvious from the graph visualization. And so this is a pretty good tool that, hey, you can use this graph visualization to quickly establish that, that there's communication to a C2 server. And then you can then use the SQL notebooks and the SQL queries to actually deep dive into the exact queries, the exact data if needed. So I hope you found this interesting. This was at least very cool for me. I'll probably do a deep dive on Graphistry and investigation in a future episode. See you next time.